Hello there and welcome back. In the last video, we talked about data types, literals, and variables all together to build a solid foundation. Now, let us dive deeper into each of them, starting with data types. There are some examples on the screen. Take your time and take a look at each of them and try to categorize them. Are they numbers, words, or maybe something else? If they are numbers, what kind of numbers? Are they integers, whole numbers, or real numbers? Feel free to pause the video if you need more time. I hope you have your answers ready. So let's get started. In the context without a programming language, the first one is an integer. The second one is a decimal number, and so is the third one. The next three are examples of text. However, if we take programming languages into consideration and we talk specifically about Java, the classification changes. The first one is still an integer. The next one is a decimal number, also called floating point number in Java. And so is the third one. This will also be a floating point number in Java. The last one is a character, and the second last one is called string in Java. For the third last one, it is a value that tells a simple yes or no, true or false in Java, and it is called Boolean. We will explore all of these shortly, but for now, notice how these examples shows different kinds of information that we can use and work with. For examples, we have got numbers which we can add or print. We also have got a string which we can print. This information is called data. And as we have seen, each of them belongs to a type. The types to which it can be categorized are called data types. So data types define the kind of value that a particular variable can hold, like whole numbers, string, Boolean, real numbers, etc. Not just this, data types gives a lot of other information as well, which we will discuss towards the end of the video. Continuing with the examples, the number 827 is an integer. 98.13 and 3.1415926 are floating point numbers. True is a Boolean and H is a character. All of these are examples of what we call as simple data types in Java. They're also called primitive data types. And by definition, primitive data types are the ones that are predefined by the language. And they're the simplest kind built into Java. Other than simple data types, we also have something called complex data types, which are also called reference data types in Java. The hello world that you see over here, which is of type string, is an example of one. Another complex data type is an array. For this video, we will focus our attention to primitive or simple data types. For string and array, we will have separate videos dedicated solely to them. Now, let us talk about the primitive data types available in Java. Java defines 8 of them, and they are byte, short, int, long, char, float, double, and Boolean. These can be put into 4 different groups. The first group contains byte, short, int, and long, and this can be put in the integers group. The data types in this group is used for both positive and negative numbers without a decimal point. The next group contains char, and this can be put in the character group. This data type is used for a set of alphabets, digits, and special characters that are valid in the Java programming language. For example, 1 or hyphen or say F. The next group contains float and double. Float and double comes under the floating point numbers, and they are used for fractional numbers, that is numbers with decimal point. And the last one is Boolean, that comes under the Boolean group, and it is a special type for representing true or false values. This will come in handy when we talk about iteration and conditional statements. Next, let us take a look at each of these categories and discuss each data type that comes under these categories. The first category that we will take a look at is integers. And as we have discussed already, there are 4 data types in the integers category, and they are byte, short, int, and long. All of these can have both positive and negative numbers, but all those numbers should be without a decimal point. The first one that we will discuss about is byte. And byte is the smallest data type in terms of the memory that it occupies and the range of values that can be put in a variable that is declared as byte. Byte is an 8-bit data type, and the range of values that it can hold is from -128 to 127, which means if there's a variable, let's say A, which is of byte type, the least number that we can put in that variable is minus 128, and the maximum number that we can put is 127. Again, in this video as well, I'm not going into the specifics of why a byte variable can hold numbers from minus 128 to 127 and not beyond that. If you want me to talk about that, please let me know in the comments and I'll make a separate video explaining all of these. Continuing, let us talk about the short data type. The short data type is a 16-bit type and its range is from minus 32,768 to 32,767. The next one is int, and this is the most commonly used data type in the integers category. Int is a 32-bit data type, and the range of values that it can hold is from minus 2,147,483,648 all the way up to 2,147,483,647. The last one that we are going to talk about is long. And long is a 64-bit type, which means it occupies 64-bit. That is, if we declare a variable, say a, and we specify that a belongs to the long type, it will occupy 64 bits of memory. And the range of values that long can hold is minus 9, 223, 372, 036, 854, 775, 808, all the way up to 9, 223, 372, 036, 854, 775, 807. And long is useful when the data that you want to store cannot be fit in the int data type because the data is beyond the range of values that an int variable can hold. Now, as we have seen, integers type provides us with 4 different data types: byte, short, int, and long, all of which occupies different memory size and can hold numbers in different ranges. And these 4 different data types makes it easier for us to choose the most suitable one according to our needs. For example, if you have to store someone's age, you can go for byte because the range of byte is from minus 128 to 127, which is sufficient for storing someone's age, and it occupies only 8-bit. However, it's not syntactically incorrect to store it in int or long, but you would be occupying 32 bits and 64 bits respectively. So if you know that the number that you want to store is going to be small, you can use a smaller data type. On the other hand, if you know that the number that you're going to store, for example, the population of a city or a country, you can go for larger data types like int and long. And this flexibility helps your program run efficiently by using just enough memory for the data that you want to store. Having said this, I should also clarify that using byte or short instead of int might not always be as efficient. If you look at it, byte occupies just 8-bit, short occupies 16-bit, whereas int occupies 32-bit. They also have got different ranges of numbers that they can store. So for smaller numbers, byte or short might seem like a good choice, but it is not always the case. For example, if we use byte or short in an expression like 72 plus 36, Java will automatically promote them to int when evaluating that expression. And because of this automatic promotion, using int directly instead of using byte or short is often simpler and more efficient for most calculations. However, if you only need to store values in variables without any arithmetic involved, then using byte or short can help reduce overall memory usage. Next, let us talk about the floating point types. And as we know already, the floating point types has got 2 data types, float and double. These data types are used to store numbers with decimal points in them. Now, float is a 32-bit type. That means a variable declared float will occupy 32 bits of memory. Double, on the other hand, is 64-bit type, which means that a variable declared double will occupy 64 bits of memory. And as we know, both of these are used for storing numbers with decimal points in them. However, float is preferred when you need to store decimal numbers, but not with a very large precision, because float can handle up to 7 significant decimal digits, whereas double can handle up to 15 significant decimal digits. And the range of float is from 1.4 into 10 to the power minus 45 all the way up to 3.4 into 10 to the power 38. That means float can store numbers between this and this, whereas double can store numbers between 4.9 into 10 to the power minus 324, which is a very small number, almost equal to 0, all the way up to 1.8 into 10 to the power 308. Next, let us talk about the characters group. And as we know, this group has only one data type, which is char. Char is a 16-bit type, which means if we declare a variable to be of char type, it will occupy 16 bits in the memory. And char is used to store alphabets, digits, and special characters that are valid in Java. In one of the previous videos, I talked about string representation, and I had mentioned that how computers use Unicode because Unicode is capable of representing any character, that is any alphabet, any symbol, any digit that exists across various languages across the world. And in that same video, I had talked about ASCII, which stands for American Standard Code for Information Interchange. There, I had mentioned that alphabets from A to Z in uppercase is assigned numbers from 65 all the way up to 90, and alphabets from A to Z in lowercase is assigned numbers from 97 all the way up to 122, which means capital A is 65, capital B is 66, and so on, all the way up to capital Z, which is 90. And similarly, small a is 97, small b is 98, all the way up to small z, which is 122. So this tells us that characters are given numbers. And as we have discussed now, the char data type is used to store characters, which means it will have a range and that range will be a number. And that range is 0 to 65535, which means the least value that a variable of char type can hold is 0 and the most value is 65,535. And because all of the characters are mapped to a positive number, ASCII does not support negative numbers. Lastly, let us talk about Booleans. And as we know, Booleans has got only one data type, which is Boolean. And a variable declared Boolean can have either true or false stored. Now, all this while, we have seen that primitive type has explicit ranges. And if Java is not the first language that you're learning and you're familiar with C and C++, you might know that languages like C and C++ allows the size of integer to vary based on the environment it is executing in. For example, it may allow 32 bits in Linux and say 64 bits in Windows. However, Java handles this differently, and the primary reason for this is the requirement of portability. That is, a Java program written in one environment, say Linux, should run exactly the same way in Windows. And that is why all the data types have got strictly defined range. For example, an int is always 32 bits regardless of the platform the program is executing in. And this ensures that a Java program written in one environment executes exactly the same way in another environment. Now, in the beginning, I had mentioned that data types provide some information. So let's talk about it. For that, let's declare a variable because we know how to, and talk about what information can a variable x belonging to type int can provide to us or the computer. First of all, data types tells us the kind of data that x can hold. If you see int x written, you can very well figure out that x is going to hold integers in a certain range and it will occupy 32 bits of memory. So the first information that data types can give us is the kind of data that a variable can hold. And it also tells us the memory requirements. Next, it also tells us the kind of operations that you can perform on the variable. For example, if I declare another variable called b and make it of Boolean type, and we compare it with variable x, which is of int type, will you be able to tell what kind of operations can be performed on x and b? Well, yes. Because x is of int type, we can perform operations like addition, subtraction, multiplication, and division, right? But we cannot do the same thing on Boolean because Boolean can only store true or false, and operations like addition, subtraction, multiplication, and division do not apply on true or false. So valid operation is another information that data type gives us. Now, these information, that is specifying the kind of data, the amount of memory, and the operation that are valid on any variable belonging to any data type, helps both compiler and the developer. Let's see how. So declaring b to be of type Boolean will tell the compiler that some operations like addition, subtraction, multiplication, and division is not permitted on b. And if the code contains such operation, compiler will be able to catch it early on and throw an error. Similarly, to the developers, data type help them understand the intended use of a particular variable. And this makes code clearer and easy to maintain. And that brings us to the end of the video. Summarizing, we talked about the 8 primitive data types available in Java, and we also talked about the categorization of those 8 data types in 4 different groups. Not just this, we discussed about the memory that any variable of a certain data type will occupy and the range of values that a variable of a certain data type can hold. Lastly, we also talked about the information that data types provides us. So that is all for this video. I hope I've been able to teach you something new and useful. If you have any feedback, suggestions, or queries, feel free to put them in the comments. Thank you so much for watching, and I'll see you in the next one.